Welcome to solving rational functions by multiplying by the least common denominator. All right, so first of all, we always have to factor if any of our denominators, or numerators or denominators, can be factored. So x minus 3, nothing to factor there, nothing to factor with a negative 6, but x squared minus 8x plus 15 can be factored. Right? We have a quadratic there. All right, so just as a reminder how to factor, right? So a here is 1, and b is negative 8, c is 15. 1 times 15, a times c is 15. We need two numbers that multiply to give us 15, but add to give us our b term of negative 8. And of course, those would be negative 5 and negative 3. Right? So then, this is a reminder of how to factor. We replace the middle term, so we have x squared minus 5x plus negative 3x plus 15 equals 0. Just the b term is replaced. And the first two become a group and the second two become a group. We'll pull out the x, and we have x minus 5. We'll factor out a negative 3, and we'll be left with x plus 5. Right? And then, I don't know why I have it set equal to 0. We're not solving. We're just factoring. Force a habit there. All right, and so then what we pulled out is one factor, and the repeating is the other. All right, so we have the repeating, I wrote x plus 5. That should be x minus 5, because 15 divided by negative 3 is negative 5. Sorry, x minus 5. All right, so the repeating x minus 5 is one factor, and what we pulled out, x minus 3, is the other factor. So we're going to replace the x squared minus 8x plus 15 with x minus 5 and an x times x minus 3. And now we need to eliminate our denominator to solve. So each of the expressions, each side of our equation has x minus 3 in the denominator. So we need one factor of x minus 3. And then on the right-hand side, we also have a factor of x minus 5. Right? So we need one x minus 3 because nobody has more than 1. And we need one factor of x minus 5 because nobody has more than 1. And that's our least common denominator. So we're going to multiply both sides of our equation by x minus 5 times x minus 3. We're going to multiply the left-hand side, and we're going to multiply the right-hand side. And there's only one term on each side of our equation. So on each side of our equation. Right? And so now we'll multiply this side too by, so squeeze it in here, x minus 5 times x minus 3. On the right-hand side, that cancels out that denominator completely. And on the left-hand side, we'll cancel out the x minus 3, and we'll leave x minus 5 in the numerator. All right, so on the left-hand side, we have x times x minus 5. On the right-hand side, we just have negative 6 because everything else was canceled. We'll multiply x times x minus 5. That's going to give us x squared minus 5x. And now we need to add 6 to both sides because we have to set our equation equal to 0 to be able to factor. So we have x squared minus 5x plus 6 equals 0. We need two numbers. 1 times 6 is 6. Two numbers that multiply to give us 6, but add to give us our b term of negative 5. And of course, that would be negative 3. And equals there, and negative 2. Right? So we have x squared minus 3x plus negative 2x plus 6. We've replaced the negative 5x with a negative 3x and a negative 2x. And now that we have four terms, we can factor out the x, and we have left an x minus 3. Factor out the negative 2. If we divide by negative 2, we're going to have an x minus 3. So what we pulled out, x minus 2 is one factor, and got the equals 0 here. And the repeating x minus 3 is the other. And I believe this one is in your notes, so make sure you're following along, taking notes. And if you need more time, of course, you can always pause the tape. So if x minus 2 is 0, x equals 2 is one solution. If x minus 3 is 0, x equals 3 is the other solution. Of course, we have to check our solutions. Now, I think I have some room on the next page. Right? So we'll check the two solutions, 2 and 3. So not complicated, just got a few steps here, but I think pretty straightforward, and we pretty much do the same things each time. So let's check those two solutions. Right? So always check your solutions to rational equations. All right, so we have to check the 2 and check the 3. I'm just going to move the whole thing here. All right, so here I've got kind of both of the equations. I plugged in on the left-hand side, I plugged in x equals 3. On the right-hand side, I plugged in the x equals 2. Let's look at the right-hand side first. All right, so we have x divided by x minus 3 equals negative 6 divided by x squared minus 8x plus 15. And we plug in the 2 everywhere we see an x. So we have 2 over 2 minus 3 equals negative 6 over 2 squared minus 8 times 2 plus 15. All right, so 2 minus 3 is negative 1, so we got 2 divided by negative 1. And then 2 squared is 4, minus 8 times 2 is 16, and then plus 15. All right, so 4 minus 16 is negative 12. Negative 12 plus 15 is 3. So 2 divided by negative 1 is negative 2, and negative 6 divided by 3 is negative 2. That solution checks out. Right? We have the same thing on both sides, and that is a real number. Let's look what happens when we check the 3. All right, so now we plug 3 everywhere we see an x. So now we have 3 divided by 3 minus 3 equals negative 6 divided by 3 squared minus 8 times 3 plus 15. There's no point in even simplifying the rest of the equation because we have 3 over 0. All right, so not a solution. X equals 3 makes one rational expression undefined. The denominator of a fraction can never be 0. We're done. Nobody cares what the other side is because we have 0 on one part of our denominator. So right here, this is undefined. And that's the end of that check because that solution will not work. So we have two solutions. One of them is good, x equals 2. X equals 3 is what's known as an extraneous solution. Right, that is our extraneous solution, and it doesn't solve the equation. Right? It's the one we got. We did all the right work, but it gives us an answer that does not work. Right? And sometimes that happens, right, when we've got a quadratic to solve. We get two answers there, but one of them is not a good answer in terms of the equation. Okay, so we have one solution and one extraneous solution. Okay? So let's continue on, and of course you can ask me questions in class if you have any questions about this problem. All right, so in the last problem we could just have cross multiplied. Right? Of course, I was trying to teach you how to use least common denominator. So if we had cross multiplied, we would have had one term to the third power, and unless we reduced first. Right? So now we could reduce that x minus 3. Now you have to remember that we canceled that out. It was there. No matter what, 3 is an extraneous solution, even if we cancel it out. Right? So x equals 2 is a solution. X equals 3 is an extraneous solution, even if we reduce first and cancel it. We just have to remember that we did that. Okay? All right, and if we don't cancel it out, we've got x times x squared minus 8x plus 4 equals negative 6 times x minus 3. Right? And both of those could be solved. Right? So, by the way, let's just take a look at what happens if we cross multiplied and didn't reduce. If we do that, we've got negative 6 times x minus 3. So this is without reducing. And no matter what, this is the 3 is an extraneous solution and the 2 is an actual solution. Let's see if we get any more extraneous solutions. So if we, without reducing, we have negative 6 times x minus 3 equals, and then we would have x times x squared minus 8x plus 15. Right? And so this would give us negative 6x minus plus 18 equals, this would be x cubed minus 8x squared plus 15x. And again, we'd move everything to one side, so we'd add the 6x and we'd subtract the 18. And that would give us 0 equals x cubed minus 8x squared plus 15, excuse me, well, yes, I forgot to write it over here though, 6x. And I should really write the 6x next to 15x. And then the negative 18. I forgot to write those two terms on the other side. Let's fix that. So 15x and 6x gives us 21x minus 18. And then we'd have to solve this. Right? And notice factor by grouping wouldn't work here. We'd have to solve using our rational root test. And synthetic division. I don't really have a whole lot of space to do that in. However, since we know 2 is a solution, 2 should also work when we plug it in here. I'm not going to take the time on the tape here to go through what happens if we didn't reduce, but you can see we have something a little bit more complicated to solve, right? And we might get another extraneous solution because we didn't reduce, right? But probably that extraneous solution is just going to be a repeating solution again because we already have one extraneous solution. Can't imagine what the other extraneous solution would be. Maybe I can do this one real quickly. So if we divided by 2, we would have, so it would be 1, -8, 21, and -18. 2 should work because that was a solution. So bring down the 1 and give us 2. This is a -6. -6 times 2 is -12. That gives us 9, 18, 0. So actually, what we've got left, actually, I can actually squeeze this in here. We do get another extraneous solution, but look what it is. So x squared minus 6x plus 9, that's a perfect square, right? That's going to factor to x minus 3 and x minus 3. So we do get another extraneous solution. It's just another 3, right? So here, a little easier if we reduce first. Just remember, even if we cancel it out, that is an extraneous solution. What we ended up doing is we ended up canceling out the second x minus 3 when we reduced up here, right? But we have 2 solutions. Only one of them is a good solution. The other one's extraneous. It's extra. All right, let's look at another problem. And this one really is another problem, not just another way to solve the same problem. All right, so here we have 9/10 plus 2x plus 5 equals 2/5. Nothing to factor, so we're done factoring. Now, we want to make sure we use the least common denominator, right? So 10 is 2 times 5, right? And then we have an x plus 1, and we have a 5. So we need one factor of 5. We need one factor of x plus 1. But do we really need a factor of 10? Not really, because we already got one factor of 5. Do we need another one? Nope, nobody's got more than one factor of 5. So what we really only need, we just need the 2, right? The 2 and the 5 got the 10 covered, and they got the 5 covered, right? And then we need an x plus 1. So our least common denominator is 2 times 5 times x plus 1. Don't multiply them together, just leave them like that. It will make it much easier for us to simplify, right? Because we can reduce when it's all factored out. All right, so we're going to multiply each of our terms here by 2 times 5 times x plus 1. So we have to multiply the first term by 2 times 5 times x plus 1. So that's times 9/10. Plus, we have to multiply the 2 divided by x plus 1 by 2 times 5 times x plus 1. And we have to multiply the 2/5 by 2 times 5 times x plus 1, right? And that would go to each term, and we cancel. So here we have 2 terms on one side. So it's much easier to, instead of trying to distribute and remember, which thing cancels out and which thing still has the term, it's just much easier to multiply it by each term because we would have had to distribute anyway. This just makes it easier. Okay? So the 2 and the 5 will cancel out the 10. Right? And so for the first term, we're going to be left with a 9 times x plus 1. Right? And now if we move over a little bit, x plus 1 is going to get canceled with the x plus 1 in the denominator. So we're going to be left with a 2 times 5 times 2. And then the 5 will cancel with the 5 in the denominator. And it's going to be equal to 2 times x plus 1. Make sure you're careful and you write down everything that's left over. Okay. So now we need to distribute and simplify our terms. 9 times x plus 1 is 9x plus 9. 2 times 5 times 2 is 20. 2 times 2 is 4, and 4 times x is 4x, and 4 times 1 is 4. Now notice here we don't have any x squareds. So that just means we're going to get all the variables on one side, all the constants on the other. So let's move the variables to the left since The largest variable is on the left-hand side. So we're going to subtract 4x from both sides. And we'll move the constants to the right. So 9 plus 29 is 29. We're going to subtract 29 from both sides. I didn't take an extra step just to write 9 plus 20 is 29. We're just going to subtract the negative 29 from both sides. All right, so on the left-hand side, we're left with the 5x. On the right-hand side, 4 minus 29 is a negative 25. This is a pretty easy problem to solve. And you just divide both sides by 5, and x is negative 5. And now we need to check, I don't know why it says solutions, because there was only solution. One solution, let's check that out. Let me see if I left space on the other side. I did. All right, so since I have space over there, our one solution was x equals negative 5. Is it a good solution? Let's find out. All right, so we have 9/10 plus 2 divided by x plus 1 equals 2/5, and we're going to plug in negative 5. Nothing to plug in the first fraction, so we have 9/10 plus 2 divided by negative 5 plus 1 equals 2/5. All right, so 9/10 plus negative 5 plus 1 is negative 4. That reduces to negative 1/2. So I've got 9/10 minus 1/2 equals 2/5. We need to have a common denominator. 1/2 is the same as 5/10. 2/5 is the same as 4/10. So 9/10 minus 5/10, that's 4/10, and 4/10 pretty much equals 4/10. All right, so that one checks out. We have one solution. We don't have any extraneous solutions. All right, one solution, and that's negative 5. All right, let's look at the next one. I don't think there's too many more problems left. All right, so here we have 2x divided by x minus 2 minus 4x minus 1 divided by 3x plus 2 equals 17x plus 4 divided by 3x squared minus 4x minus 4. And now we need to factor anywhere we can factor. So step number 1, and by the way, make sure you're looking to see if this one's in your notes. And even if it's not, it might not be a bad one to write down. Step 1, number 1 is factoring. There's nothing to factor in the first term. 2x divided by x minus 2, I've got nothing to factor there. I have nothing to factor in 4x minus 1 and 3x plus 2. I've got nothing to factor in 17x plus 4. Nothing I can pull out of those two. But I can factor 3x squared minus 4x minus 4. All right, so A is 3, and B is negative 4, and C is negative 4. So 3 times negative 4 is negative 12. We need two numbers that multiply to give us negative 12, but add to give us our B term of negative 4. And hopefully you're saying negative 6 times 2 would be negative 12, and negative 6 plus 2 would be negative 4. All right, so that's going to give us 3x squared minus 6x plus 2x minus 4. Okay, we just replace the negative 4 with a negative 6x and a 2x. And the first two become a group, and the second two become a group. We're just undoing the multiplication process. So we can pull out 3x out of both those terms. We're going to be left with an x minus 2. And we can pull out a 2 from both the terms, and we're left with x minus 2. So factored, this would be 3x plus 2 times x minus 2. And interestingly, there's a 3x plus 2 in one of the other fractions, and there's an x minus 2 in one of the fractions. The one thing you can't do, you cannot cancel anything, right? Cannot cancel, right? Because we have more, it's not just 2 terms, we have 3 terms, right? So you can't just be canceling out from any old term you feel like. You can't cancel out things that are added and subtracted. The 2x divided by x minus 2 is subtracted with the 4x minus 1. So there's an operation between those two, so we cannot cancel anything. What we can do, though, is multiply by the least common denominator. So we're going to multiply by the least common denominator. So we need an x minus 2 because the first expression has an x minus 2 in the denominator, and so does the one on the right there. And we need a 3x plus 2. Because the second expression has a 3x plus 2, and so does the one on the right. So this is going to be our least common denominator, and we're going to multiply every term by x minus 2 times 3x plus 2. So this guy needs an x minus 2 times 3x plus 2. And the next one needs a x minus 2 times 3x plus 2. Ooh, I don't know if I can fit everybody in here. I think I need to scroll down just a little bit. I'm out of space. Just going to move this down just a little bit. And then the last term. So 17x plus 4 divided by 3x plus 2 and x minus 2. So he needs to be multiplied by a 3x plus 2, x minus 2. All right, so now we'll simplify. So technically these are all over 1 if that helps you. That's in the numerator and 1's in the denominator. So the x minus 2 will cancel, right? And we're going to be left with, I'm going to write the 2x first. 2x times 3x plus 2. And then the 3x plus 2 will cancel. And we're going to be left with a minus x minus 2 times 4x minus 1. And then here, this will all cancel. So that's just going to be a 17x plus 4. All right, so now we'll multiply. 2x times 3x is 6x squared. 2x times 2 is 4x. Be very careful. I'm going to leave this minus sign here and put parentheses. We have to remember to distribute that negative sign to everybody. You're subtracting the whole thing. You can't just make one thing negative. It's everything. All right, so x times 4x is going to give us 4x squared. The outer terms, x times negative 1 is going to be a negative x. Negative 2 times 4x is a negative 8x. And negative 2 times negative 1 is a positive 2. Equals 17x plus 4. Wish I had written just a little bit smaller here, because I could really use just a teeny bit more space. Let's see if I just move this up just a little bit, and oops, that up a little bit. Can I get everything to move up? There we go. And oops, a little too far. That, and that, and that. And then maybe I can get all this. Oops, too far, too far, too far. There we go. That gives me a little bit more space. It's nice to be able to move things around. All right, so now we're gonna combine like terms and distribute the negative. So I've got 6x squared plus 4x minus, and this whole thing is going to be subtracted. So we have 4x squared. Let's combine those two terms. Minus 9x plus 2 equals 17x plus 4. All right, so we distribute the negative sign. So now we have 6x squared plus 4x. Come on, writing. Minus, oops, 4x squared. Negative times a negative is a plus, plus 9x and minus 2. If you don't distribute that right, there's no way you're going to have a right answer because you've got a mistake. We're going to combine the like terms. We can combine the 6x squared and the negative 4x squared. That's going to give us 2x squared. I'm going to have to solve the rest of this on the next page. So we have 2x squared. We have a positive 4x and a positive 9x. And actually, you know what? Let's not only just add the like terms on the one side, because I'm going to go to a next page in a second. Let's also subtract the 17x and the 4. So we'll subtract the 17x, we'll subtract the 4. So we're just going to combine everything all together. Subtract the 17x and subtract the 4. And let's see, I'm going to extend the page a little bit, and then I'll scroll back up in case somebody needs to write something down. So 6x minus 4x, 6x squared minus 4x squared is going to give us 2x squared. Positive 4x, I shall underline it for you, a positive 4x, a positive 9x, and a negative 17x. So it's going to be 13 minus 17. That's going to be a negative 4x. And then we have, who's left? We have the negative 2 and the negative 4. That's negative 6. And we combined all of our like terms, right? Equals negative 17x, oops, equals 0, equals 0. And you know, that is, we could reduce, right? Because if I factor out a 2, I have x squared minus 2x minus 3 equals 0. So we could divide both sides by 2 for something easier to solve. Now I have x squared minus x, and then minus, oh, excuse me, I divided twice. Excuse me. X squared minus 2x. So we're dividing by 2. So we're left with x squared minus 2x minus 3. Let's factor that. I think I can squeeze that over here. And let me see if I can scroll up the page so people can see everything. This is probably going to be the last problem on this podcast because I don't like to go past 30 minutes. That's the maximum. For me, there we go. Now you can see everything. All right? Should have written smaller, huh? So over here, we're going to factor that x squared minus 2x minus 3 because that would cancel. And that's still 0. All right, so x squared minus 2x minus 3 equals 0. Multiplies to give us negative 3. Adds to give us negative 2. All right, that's going to be, let me squeeze that in here. That's going to be negative 3 and positive 1, right? And negative 3 plus 1 would give us the negative 2. So we have x squared minus 3x. And then plus x minus 3 equals 0. First two are a group, second two are a group. We'll factor out the x. We have an x minus 3. Factor out a 1, we have an x minus 3. And so factored, we have x plus 1 and x minus 3, which means the two solutions are x equals negative 1 and x equals 3. And we're going to check those on the next page. So we have our two solutions. Are they good? Are they extraneous? I don't know. And you know, I never wrote down any of my other steps after multiply by the least common denominator because I started to run out of space. So let me just write those down. Step 3 after that was to solve. It was actually to, let's put the whole thing up here. Well, first we had to combine, we had to simplify, right? So we distributed, we combined the like terms, and then we factored. Actually, I'll just put simplify and combine like terms because we did the factoring over there. Right? And then we factored. And then we solved for x. So there's all our steps. This was 4, and this was 5. And let's see if these are good solutions or extraneous solutions. And I think I did that on the next page. Here's the check. And then I said put it all up here so I can talk a little faster. All right, so we have the two solutions. Over here in blue is x equals 3. Over here in red is x equals negative 1. So we plug in the 3 and we check that out. So we have 2 times 3 divided by 3 minus 2 minus 4 times 3 minus 1 divided by 3 times 3 plus 2 equals 17 times 3 plus 4 divided by 3 times 3 squared minus 4 times 3 minus 4. And now it's just some simple adding and subtracting and multiplying. All right, so 2 times 3 is 6, and 3 minus 2 is 1. Right? 6 divided by 1 is 6. 4 times 3 is 12, minus 1 is 11. 3 times 3 is 9. 9 plus 2 is 11. And 11 divided by 11 should be 1. Do we have boo-boo on my check here? Let us check this out. We have 6 minus 1, right? 11 divided by 11. There's 11 in the numerator. There's 11 in the denominator. All right, I'm not seeing things, so that's minus 1. So 6 minus 1 equals, all right, so we have 17 times 3. It's going to give us 51 plus 4, and then would be 54. All right, and then we have, actually, let me make sure I have all my steps in here. So that's 54. And then 3 squared is 9, and 9 times 3 is 27. And so then we have 27 minus 12 minus 4. So on the left-hand side, that's 5 equals 54 divided by, all right, so 27 minus 12 is going to be 15, right? And 15 minus 4 is going to be 11. That's even worse. Oh, 54. Since when is 51 plus 4? 54. It's usually 55. So now we have 55 divided by 27 minus 12 minus 4. So 55 divided by 11. That one's a good solution too. That's 5 equals 5. That one checks out. Can't believe I had 11 when this should have been a 1. All right, so 51 plus 4, 55. And then divided by 27 minus 12 is 15. 15 minus 4 is 11. So 55 divided by 11 is 5. That one checks out. Ooh, I'm over my 30 minutes. Well, I'll talk fast. All right, so now in the second one, we plug in the negative 1. 2 times negative 1. It's going to give us a negative 2 divided by a negative 3. So that's just 2/3. We have 4 times negative 1 minus 1. That's going to be minus a negative 4 minus 1 is negative 5. Negative 3 plus 2 is negative 1. So that's going to be a positive 5. That's why their pluses are in there. And then 17 times negative 1 is negative 17 plus 4 is negative 13. 3, negative 1 squared is 1. So we got 3 times 1, which is 3. Actually, I'm going to move this thing out of the way here. 3 plus 4, and then minus 4 is going to give us negative 13/3, right? Those are just going to cancel out. So we have 2/3 minus 15/3 equals negative 13/3, and 2 minus 15 is negative 13. Negative 13/3 does equal negative 13/3. They're both good solutions. There's no extraneous solutions here. Here we have 2 good solutions. 2 good solutions. And that's probably going to be my last problem. I'm just curious, was this the last problem altogether? That was the last problem altogether. So no matter what, this would have been my last problem. So I hope you enjoyed the podcast, and then we'll do some whiteboard practice in class. Have a nice day. Bye.